Good afternoon. Don't stop eating. Thank you so much for coming, both those of you who are here from the Annenberg School and also those who have come from across campus and across town. Welcome to everybody. I'm Marty Kaplan. I'm the director of the Norman Lear Center here at the Annenberg School. If you don't know what the Lear Center is, what's up with that? We've been around since 2000. The Lear Center studies and shapes the impact of media and entertainment on society. I warmly invite you to come visit learcenter.org. There are seats here in the front as well. And I want to be sure to thank the people who were involved in getting us to this point. They are almost all outside working, but maybe they'll see the video. Thank all the Lear Center staff, but in particular Adam and Scott and Veronica, and in particular Veronica. So even in her absence, let her hear the thunder. Thank you. And welcome to the Everett Rogers Award Colloquium, which for some people might raise the question, who was Ev Rogers? And we'll be hearing about him today just as a thumbnail to get us going. Ev Rogers was a farm kid from Carroll, Iowa, who had no interest in going to college. He ended up going to college. At age 30, he was assistant professor of rural sociology at Ohio State University and had a new book come out called Diffusion of Innovations. And that book made him an international rock star. It is the second most cited work in social science. He ended up for a period here at the Annenberg School for about 10 years. He was associate dean and a faculty member here. There was great affection for him. He was quite a guy, and respect for his work. When he died in 2004, the dean of the Annenberg School, Jeffrey Cowan, we're in the Jeffrey Cowan Forum, set up a prize in his honor to celebrate his work and his memory, and it is that prize. Casey, there's room down here. It's that prize that we are awarding today, and thrilled to have our guest here. Mark just wanted you to know that our dean, Ernie Wilson, is back east. Sorry he can't be here, but said he's particularly bummed because you are one of his heroes. He didn't actually say bummed, but that's what it sounded like. He did say exactly, that was the key. So the award was initially given out in 2005. The first winner was Arvind Singhal, who is one of the judges of this award in the field of entertainment education, the use of entertainment in order to spread pro-social messaging, especially in the area of public health. And that particular activity is one of the signature programs of the Lear Center called Hollywood Health and Society, in which we work with television shows in order to get the health messages in their stories to be accurate, because we know the impact they have on audiences. That was an area that Ev Rogers studied. One of your colleagues, Al Bandura, won the award a couple years later. You probably know Bobo the Doll and self-efficacy. So it's been a great opportunity to bring people here and to hear from them about their work. The prize is for someone whose own work contributes path-breaking insights in areas of Ev Rogers' legacy. So what are those areas? Well, diffusion of innovation, certainly. Communication and national development, historical and social evolution of information technology, cross-cultural communication, network processes and effects, and entertainment education, as I mentioned. There is a panel of judges who met and gave out this award. There are a couple seats down here, if you don't mind being under the screen. And that panel of judges included Leo Brody, Manuel Castells, Casey Coles, who's here, Doe Mayer, Arvind Singhal, Tom Valenti, who was here, and the chair, Peter Clark, whom I'm going to cede the floor to in just a second. But first, how we're going to proceed today, Peter's going to introduce Mark. He's going to speak, and then ideally there'll be a little time for question before some people have to leave at 1. If you do have to leave, slip out. People outside will be delighted to come in and get a seat. The questions and answers will continue past 1, so if you do have the ability to stay here and haven't had a chance to ask your question, that's the way to do it. So please join me in welcoming the chair of the Ev Rogers Prize jury, my colleague here at the Annenberg School, Peter Clark.
Thank you, Marty. It's a great pleasure to see so many friends in this room and people who we hope to make new friends with our event today. Just another word about Ev Rogers, who joined the Annenberg faculty in the mid-1980s and left in the mid-1990s. I actually had the pleasure of being Ev's colleague at 2 institutions, the University of Michigan and here at USC. And everything that Marty has told you about him is true. He was not only a distinguished scholar, but a gentle and gracious and student-centered person, generous with his time and with his intellect. He's survived by Corinne Scheffner Rogers, who herself is a graduate of the Annenberg School. We're here to recognize the newest recipient of the Ev Rogers Award, Mark Granovetter, as our 2013 honoree, who knew and admired Ev, and Ev knew and admired him as well. Mark is, of course, justly famous for his strength of weak ties concept, but he's done very much more than that. He's a sociologist of industrial organization. He's very interested in issues such as threshold levels and tipping points and how the processes of industrial organization become embedded in human networks. He holds the Joan Butler Ford Chair at Stanford University. He's a fellow of the American Academy of Arts and Sciences. He's also a recipient of honorary doctorates from Sciences Po and Stockholm University. He leads a network study group at Stanford whose website I commend to you for a number of publications that have come out of that program. He's deeply interested in how networks have been important to the evolution of Silicon Valley. Something that everybody acknowledges has been the case, but has been vastly understudied. And we can look forward to more research in his program in the years to come on a topic that is of vital interest to lots of people in this room, but was also of vital interest to Ev Rogers himself. He published one of his some 30 or 35 books was on the topic of Silicon Valley and its evolution. So it gives me great pleasure to introduce to you the 2013 awardee of the Ev Rogers Award, Mark Granovetter.
Well, thank you for those gracious introductions. I hope I can live up to all that talk. I first met Everett Rogers in 1976, and there were a lot of things to appreciate about Ev Rogers, but the thing I particularly appreciated was that he was one of the first really big fans of my paper, The Strength of Weak Ties. He told everyone about it, and he would introduce me to people, and they would say, "Oh, you're that Mark Granovetter." I don't know how many others there were. And I think at this point in time, much more than at that time, social networks and networking and social media are really hot topics. People had just started to think about them in the 1970s when all this first originated. So what I want to try to do today is to explain where all these social network ideas came from and talk about what they mean in the 21st century. And along the way, I want to talk about how I came to write this paper, The Strength of Weak Ties, and how the argument of that 1973 paper applies at the present time. So let me go back to the 1930s. Probably the first coherent argument about social networks was made by a psychotherapist named Jacob Moreno in the 1930s. And Moreno was quite a strange character. He wrote a book with the ominous title, Who Shall Survive?, which was about social networks. And the book had a lot of strange things in it. For example, he talked about social networks, and he talked about how we should rearrange cities according to who likes whom. And, you know, we're probably lucky that no one paid attention to that part of the book because it wouldn't have worked out so well. But from Moreno's work came the representation of networks and network diagrams in terms of points and lines, the familiar network pictures that we all look at now, and the idea that you could measure social networks by asking people whom they liked or spent time with, what came to be called sociometric tests. They probably came to be called sociometric tests because these were mostly inflicted on children in school, because that was an audience where you could get the kids out of class because they had to do what the teachers and the administrators told them to, and anyway, it was probably more fun than what was doing in class anyway, where you would write down who your three best friends were, who the three people were that you admired or spent time with or whatever, and then they would take that data and they would construct pictures of networks from that. So these ideas about social networks entered sociology and anthropology from the 1940s to the 1960s, and along with them came the first mathematical techniques for measuring social networks, which I won't go into any detail about today, but it can be really very intricate and complex. If you look at some of the recent material on social networks, you'll see that some of it can be pretty daunting. In the 1940s came the first simple ideas, for example, that if you would represent who knew whom or who liked whom with a matrix of ones and zeros, then if you squared that matrix, you would get another matrix that gave you all the two-step connections of who likes someone else. And it went on from there and got more and more complex. Meanwhile, in pure mathematics, a field was developing called the theory of graphs. And two of the most prominent people who worked on the theory of graphs were Hungarian mathematicians named Paul Erdős and Alfred Renyi. And they developed what's called the theory of random graphs in a series of beautiful and path-breaking papers. So a random graph, so graph is just the mathematician's name for a network, where a network is a picture where there are points and lines, points being units like people and the lines being connections or ties. So a random graph is one in which the nodes, the people in a social network, throw out ties at random to other nodes, which is to say the chance of linking to any other node is the same for every other node that you might think about linking to. And it turns out that when a network is formed randomly like that, it has very high connectivity. It's very easy to get in a very small number of steps from any node to any other node when the ties are thrown out randomly. You have extremely short paths. Of course, Erdős and Renyi, even though they were pure mathematicians, they knew something. And they knew, something about, let me rephrase that. They knew something about the real world. And they knew that real social networks were not random. It was just a model. Because real people hardly choose their friends randomly. Instead, you meet friends through other friends. So you're more likely to know people whom your friends already know. Or you meet friends through taking part in similar activities. And because of that, because of the way people really make social ties, we expect people to form clusters or cliques, which is what happens in real life. And when you have clusters or cliques, then it's harder than in a random graph to reach people in other cliques through a short path, because you get stuck in a clique when you're trying to make that connection. But no one up to the 1960s had a clear idea how to think systematically about this problem. And in the 1960s, the social psychologist Stanley Milgram came along, and he got interested in this, and he started talking about something he called the small world problem. So what's the small world problem? He took the term small world from the obligatory cocktail party response that you make when you meet someone you hadn't met before, and you get to talking, as you do at a cocktail party, about where you came from and what you've done in your life. And finally you figure out that there's someone that you both know, even though you never met each other before. And when you make that connection, there's something you have to say. Everyone says. They say small world. And so this is what Milgram took as the title of his problem, the small world problem. And of course, let me just say that in a world of random networks, if people really made their friends randomly, then finding that you had a common contact with a stranger would not be a surprise, because everybody would, because the number of ties, number of links to reach someone would be very small. But that's not how it is in the real world, and so people are surprised when they find that you have a common contact with a stranger, and indeed, saying the phrase small world is a signal that we are surprised. So Milgram wanted to know, he wondered for strangers who, let's say, did not share an acquaintance, because there, after all, are some people you meet at cocktail parties that you don't find a common acquaintance with. He wondered if for strangers who did not share an acquaintance, how many personal links it would take to connect them. So, for example, if we take two people, X and Y, that we chose randomly, then how many people does it take to connect them? So if it turns out that X knows A, who knows B, who knows C, who knows D, who knows Y, and that's the shortest connection between them, that's a chain length of 4, because you had 4 people between X and Y. And so Milgram wondered if you chose any two people in the United States just randomly, throwing darts at a map or whatever method you might have, how long a chain would be needed on the average to connect them? And once he knew the answer from his experiments, which I'll tell you about in a moment, he used to tease, I would even say taunt, because he was that kind of guy. He used to tease academic audiences by asking them to guess the answer. And then he would be pleased, I think, when their answers would be wildly inaccurate. And people would say, oh, it would probably be hundreds of connections to connect randomly chosen people. But in fact, his small world experiments, the chain letter technique that he made famous, it turned out that the answer was only 6 or 7. A fact that has passed into common knowledge by now with the phrase 6 degrees of separation, which comes in part from a game involving the actor Kevin Bacon, who's been in more movies than anyone has ever seen. And also from a 1993 Will Smith movie of that same title, which I highly recommend for those of you who've never seen it. So Milgram's technique was he couldn't really choose any two random people in the United States. So what he did was he got a bunch of people, he was at Harvard at the time, got a bunch of people in the Boston area to agree to be targets. And then, Milgram was from Brooklyn, and so the most remote places he could think of in the whole world were Kansas and Nebraska. So he chose randomly people in Kansas and Nebraska, and he sent them a package identifying a target person and asking them to move this package along. If they knew them personally, which was highly unlikely, they could send the package directly to that person. If they didn't, they should send it to someone more likely than them to know. And then that person got the same instructions. And so the ultimate question was, how long would the chains be when these actually got back, when these packets actually got back to the target people? Well, I was a graduate student at Harvard at that time, and so I knew Milgram's RAs. I knew Milgram a little bit too. And so I kept track of all this, and I came into possession actually of some of these instruments. And so up here is a picture of the original instrument that Milgram sent around to people, Communications Project. Here's the target person. This was a stockbroker from Sharon, Massachusetts. And then this one went first to this person, Albert Gross, would have been in Kansas and Nebraska. I don't remember which one. Here are the instructions. And you sent off a postcard. Each time you sent it back, you sent it along to someone else, and then eventually it might reach the target person. Dana Windsor is the person here, if you can see this, if I can make this laser pointer behave. Here it is. And you can see this was a pretty short one, that there were just actually 3 people in between. And this whole, and so this is a photocopy of the original instrument. This is 1966. This looks so hokey. You know, you couldn't ever do anything that looked like this. Look at these lightning bolts up here. You know, communications project. And then, I don't know if you can read this. It says, "We need your help in an unusual scientific experiment being carried out at Harvard University," and so on, with all these instructions. And then at the end it says here, if you can read this, "Every person who participates in this project and sends back a postcard is entitled to receive a certificate of appreciation." I think you'd have to do it a little differently now. So the fact that these, when they reach their target people, that the average number of steps in between is only 6 or 7, that was very interesting to me. And I kind of filed that away, along with some other things that I was thinking about. And these results were closely related to another set of studies that I'd heard about in lectures by my mentor, a guy named Harrison White, who was one of the pioneers of network analysis in the United States, certainly in sociology. And in 1966, Harrison White was teaching the introductory course for freshmen in Harvard's Department of Social Relations, which at that time contained the Department of Sociology. He was about the worst possible choice for that course because no freshman could understand anything he was saying. And I was one of the TAs, so I got to hear all the lectures. And in fact, even though the freshmen were completely mystified by the lectures, there was a devoted graduate student following. We all loved it and were very interested in it. And one of the studies that White talked about was a study carried out by a guy named Anatole Rappaport and his colleagues, who in 1960 asked all 859 students in a junior high school in Ann Arbor, Michigan, obviously they were at University of Michigan at the time, to fill out a card, to fill out a series of cards, which stated, "My best friend in this school is," and then you had to fill in a name. And then, "My second best friend in this school is," and another name. And "My third best friend," and so on up to "My 8th best friend in this school is so-and-so." So each of the 859 students filled out those 8 cards, and this was a lot of network data. It was all the kids in the junior high school. So Rappaport knew quite well that networks weren't really random, but he was trying to find out in what ways they deviated from randomness. And he suspected that there was more what he called overlap bias among close friends, your first best friend, your second best friend, and so on, than there would be among more distant friends. In other words, the closer friends were, the more likely they were to choose the same other people as friends. So you and your first best friend, second best friends would tend to be choosing the same other best friends, much more likely than your 7th best friend, your 8th best friend. And to show this, what he did was so he had all this data, and he had to organize it somehow. So he took random samples of 9 students, and he did the following thing. He took these samples, and for these 9 students, he would put their names on a list. And then he would take the names of their first and second best friends that they named, and add them to the list. So then you'd have 9 plus 18 is 27, except you might not have 27 because some of the 9 might name the same first and second best friends as one another. So it would be 27 or less, 18 plus 9 at one remove. And then he would take the people at the second remove, the 18 people or less named at the second remove, and look to see who their first and second best friends were. So you have this branching out like a tree. And he kept doing that until finally, at some remove, no new names were being added to the list. And they did the same procedure for 3rd and 4th best friends, for 5th and 6th best friends, and for 7th and 8th best friends. And what they expected was that the first and second best friends would be a lot more likely to name students who were already on the list. They would name the same people as their friends named, than the 7th and 8th best friends would. And therefore, you'd eventually have a much shorter list for the first and second best friends, than you would for the 7th and 8th best friends. You'd reach a lot more people through 7th and 8th best friends than you would through 1st and 2nd best friends. And all of this data is in the articles by Rappaport and his collaborator Horvath, but it's kind of hard to sort through that. So one of the other TAs for Harrison White's course compiled a graph which summarized the Rappaport and Horvath data. And here's what the graphs show. That if you look at 1st and 2nd choices, that's the bottom line here, then this is how many people you eventually reach. This goes out 12 removes, and we stopped it after 12 removes because the numbers aren't changing very much after that point. It's, you'd say, at asymptotes at that point. And so what you see is that the total number reached through 1st and 2nd best friends is only about 175 out of the 851. The number reached through I guess I've got, it says 6th and 7th up there, but it actually should be 7th and 8th. And that number is about 375. So you reach a lot more people through 7th and 8th best friends than you do through 1st and 2nd. And if you did the 3rd and 4th, 5th and 6th, they would fall in between. So the original guess was right, that you reach a lot more people through your 7th and 8th best friends, your much weaker ties. And that was a very strong and impressive result. It turns out also that if you drew a random network where ties were thrown out randomly, which Rappaport had to simulate because there were no real random networks here, then you reach this many people. And then if you do what's called a planned network, where everyone has to choose someone who hasn't already been chosen, then you reach almost everybody, which is this graph up here. So this very strong and impressive result, which was more or less the one Rappaport expected. But he didn't do much with it. He used it mainly to argue some rather technical points about network parameters. Anyone who's interested, I can refer you to the original set of articles. And I was guessing that the finding was more interesting than that. And in my mind, it had something to do with the small world results. So when I got around to doing my dissertation research, which was on how people use social networks to find jobs, which is summarized in my book called Getting a Job, which still in print, you can buy it on Amazon, shameless plug. And if you go to the website, they'll say, you know, like they always do, only 3 left in stock. And, you know, if you believe that, I have a bridge I can sell you. So when I got around to the dissertation research on how people find jobs through social networks, I was interested in information flow. And I still had the results in mind from the Milgram experiments and from the Rappaport experiments. And when my respondents surprised me with some of their answers, I started putting 2 and 2 together. I was interested in information flow. That was a big topic, certainly when you're talking about people finding jobs. A lot of it is about information flow. And I thought that how many of a person's friends knew each other, what proportion of the ties among your friends are actually there, possible ties among your friends are actually there, something that was called egocentric network density in that literature. I thought that would be perhaps an important influence on information flow. And so in my pilot study, I made a chart, a little picture, with each respondent at the center, and then I had boxes around and lines to the boxes. And I asked each person to name the people, the 5 people they spent the most time with. And I put their initials in those boxes. And what I intended, I asked them which of these people knew each other. So I had a measure of network density for their people they spent a lot of time with. And what I was trying to do was, I was thinking that when they told me whether or not they found a job through personal contacts, which is a question I asked them, I'd look at this network picture and I would see whether whether network density was different for people who found jobs through contacts from that, for people who did not find jobs through contacts. And the problem was, and the reason that you won't find these charts in my book at all, is that none of the people who helped my respondents find a job ever showed up in these charts at all. They were not there, absolutely not there, because they were almost never close friends. You know, these were the people I spent the most time with. They were close friends. They never were the ones who helped these people find their jobs, and that was kind of surprising to me at first. And in fact, sometimes I would say, I would say, how did you find your job? They would say, oh, so-and-so told me. And I'd say, oh, a friend told you. And over and over again, people corrected me and said, oh, no, just an acquaintance. Just an acquaintance. Well, you know, one of the things about doing research where you actually talk to people is that you need to listen. You actually need to listen and try to understand what they're telling you instead of just, you know, sliding past it or correcting them as if you know something about themselves that they don't know. And so I listened and I thought about this, and the puzzle was, why would people be finding jobs mainly through weak ties than through strong ties? So I thought about it, and I thought about the Milgram results, and I thought about the Rappaport results, and I realized that what was going on here was that because your strong ties know the same people you know, this is the overlap bias, that they might be great sources of social and emotional support. You know, we need our close friends. I'm not telling you to get rid of all your close friends and stick to acquaintances. We need them, but they may not be great sources of information because they're talking to the same people you're talking to. They're hearing the same things you're talking to. It's what we call redundancy. Whereas your weak ties, the people you don't know so well, they move in circles that are different from your own. And they are much more likely to link you to ideas and information that are distant from you, that you didn't already know. So they're really, in an important sense, your windows on the world. Now, I could mention also, so this is all these things coming together in my head and making me think about this. And let me just mention, this is a little bit parenthetical because it didn't make its way into the article, but I did remember from my college chemistry course that one of the most important cohesive forces, both within and especially between molecules, was something called hydrogen bonds. Any of you who've taken a chemistry course will know what that is. They are much weaker than other kinds of bonds, like covalent bonds or ionic bonds. And because of that, they're able to hold together much larger chemical structures than the stronger ties are. All these thoughts came together, but I left out the chemistry part because I didn't want it to sound like I was crazy, and trying to megalomaniacal, whatever. So I left that part out, but now that I won a prize, I'm allowed to say it. So all of these thoughts came together in a paper I drafted before finishing my dissertation, and I called the paper Alienation Reconsidered, and the subtitle was The Strength of Weak Ties. And I called it Alienation Reconsidered because there was already a large literature out there arguing that the prevalence of weak ties, weak social attachments in modern society, was a bad thing. It led to alienation. And I wanted to show that, in fact, weak ties had a kind of strength that was very important that strong ties didn't have, which could lead to important outcomes, like finding out about a good job. That's not anything to be sneezed at. Unfortunately, the American Sociological Review, which was the journal I chose to bestow this paper upon, referred it to alienation theorists who just despised it. The first line of the first journal review I ever got in my academic career read, "Among the innumerable reasons why this paper should not be published, I list the following 6. This was a little discouraging, and the paper was, of course, rejected. Well, so this sent me into a little bit of a funk, and so when I finally got back to the paper a year or two later, I wisely dropped the alienation part of the title and retitled it simply The Strength of Weak Ties. And then it was published in 1973 by the American Journal of Sociology. And apparently it answered a lot of questions people had been asking because it immediately started drawing an amazing number of citations, which, according to Google Scholar, is now in excess of 25,000, which I find quite amazing. I don't know why people don't have anything better to do than to sit at home and cite my paper. I think they should probably get out more, but I can't control people's behavior. Among the questions that the paper answered, I think, is how it could be that Milgram's 6 degrees of separation was not a much larger number that many people's intuition suggested. And I think what it showed is that although there are many distinct social circles separating randomly chosen individuals in the United States, but people figured out without ever having a course in network analysis, that they could reach across social circles by using their weak ties. And so if you think about what networks look like, and if I can make this, oh, yeah, okay, I need a down arrow, yes, okay, got it. So if you have a network that looks, I'm not sure how to make this go part way, but anyway, this will have to do it. So here's a kind of a make-believe network, and you can see that there are cliques in the network, and the cliques are connected by these probably weak ties. Part of the argument of the strength of weak ties is that there are cliques, but the cliques tend to be connected, if they're connected, by relatively weak ties. And people figure that out. They figured out that they shouldn't, if they're in Nebraska and trying to reach this stockbroker in Sharon, Massachusetts, they shouldn't send it to their cousin. They should send it to someone who's a much weaker tie, their minister, or someone who probably gets around in other circles. And so people figured that out. And I think the article showed that weak ties reduce the path length that it takes to connect randomly chosen people in a dramatic way. In the 1990s, a whole new wave of very formal work began on the small world problem, beginning with what is now the well-known work of Duncan Watts and Stephen Strogatz. And when they did that, more light was shed on these issues. So Watts and Strogatz, in a famous paper that appeared in 1998 in the journal Nature, showed that there were really two parameters of interest in the study of social networks. One was how clustered or clique networks were, so a kind of index of clustering. And the other was what was the smallest path that would connect any two randomly chosen nodes, so a measure of path length. And what they showed was the following. So let me show you a table here. So here's the puzzle. The puzzle is that if you had random networks are networks where there's not much clustering because people are choosing their friends randomly, and the average path length is low. It's easy to get from anybody to anybody else because you don't have cliques blocking that process. If you have a network that's got a lot of cliques, which is what this upper left-hand cell is, then there's a lot of clustering, and the average path length is high. It's hard to get out of cliques to reach people randomly. So the puzzle is that in the real world, what you have is what Milgram found, which is what he calls small world networks, which is that there's still a lot of clustering. There's obviously, we know there's a lot of clustering in the world. So clustering coefficient is high, and yet the average path length is low. It's 6 or 7. So how come that's what the real world looks like? And I think that the strength of weak ties paper pretty much answers that question. And what Watts and Strogatz showed was that if you took networks that were highly clustered, very totally cliqued, and then you just rewired, as they said, a very small proportion of ties. So let's go back to here. So if you have this picture here, okay, where's my little red dot here? There it is. You have this picture here. They would take ties within these cliques, and they would randomly rewire them so they went to other cliques. And they found that if they did that in a very large network, and they did this with a simulation, so these weren't real network data, that it was remarkable. Of course, when the network was highly cliqued, then the path length was very high. It was very hard to get from any random point to any other point. But if you just did a little bit of this rewiring, then the path coefficient went down so dramatically that once you finished rewiring maybe 8 or 10% of the ties, the path length coefficient was about the same as it would be in a random network. It just went down so dramatically. And this is kind of what the real world looks like. It's these weak ties that are making these connections between cliques. So that's why the real world network looks like a small world network. There's one other important point about these ideas that I want to make. Let's go back to this small world comment you make at cocktail parties when you learn you share an acquaintance with somebody you just met. Well, this very shows that you're surprised at your own social network. And that surprise reflects ignorance of your network, and that ignorance is an absolutely fundamental social fact, very important social fact. Because suppose you know 500 people. It's not so unusual for people to know 500 people. You'd have to take you a while to write them down, but it's not too unusual. In order for you to know which of those 500 people know which of the other 500 people, Well, the number of possible ties among 500 nodes is 500 times 499 over 2, as you can convince yourself pretty easily if you make a picture. And that is approximately 125,000. That's a lot of information, a lot of bits, as the information people would say, to keep in your head. And nobody keeps that in their head. So that's already, just for your own friends, too much to know. And if each of those 500 already also knows 500 more, then you have potentially 250,000 people at just 2 removes from you, and the number of possible ties among those people turns out to be more than 31 billion. You're obviously not going to keep that in your head, no matter how prolific a networker you are. Nobody has that kind of information in their head. Now, of course, in practice, it's not 31 billion because some of the people choose the same people as others do, but that just introduces another kind of complexity. So the details of real social networks are so complicated, and there's so many details that no one can keep that in their head. So everybody, it's not surprising that people are always saying small world, because people can't know that much about the social networks. There's just fundamental cognitive limitations. And those limitations of human cognition and time, I mean, imagine how long it would take you to find out all that stuff, even if you had a place in your brain to keep it. Not to mention the fact that you've got a life to live, competing obligations of everyday life, keep our network knowledge small and non-random. And for that reason, the 6 degrees of separation found by Milgram and subsequent researchers, that number might be too high, because no one actually knows the shortest path. These people sending out these postcards are guessing. They don't actually know the shortest path. So the parameters that he found are just an upper bound on what is really going on. Well, so until the 1990s, these limitations on our knowledge of our own networks, which are so fundamental, they were insuperable. You couldn't do anything about them. But then enormous computing power arrived right on our desktops in the 1990s, an amazing revolution, and scholars in many fields made new technical advances on old network questions. One of the new tools for this understanding was something called network visualization software. So this is important because in any real network, if you try to draw the network, there is such a tangle of points and lines that you can't, if you can draw it by hand, which is probably too hard to do by hand, you still can't see what's going on because so many lines cross that you just can't keep track of it. And that's why for many years studies of social networks were limited to collections of 50 people or less. And even then the network diagrams were incredibly complicated to look at. But now we have numerous network visualization packages, UCINet, PIAC, many others, which sort out the structure of even very large networks and make pictures where you can see what's going on. And so now networks with millions of nodes are routinely studied. This is something that now goes under the heading of computational social science. It's a fancy word for saying we can study very big data sets now, and especially social networks. So you see articles in Science about networks with millions and millions of nodes, like cell phone networks, like studies of whole countries, and every cell phone call, every time someone makes a cell phone call to someone else, the researchers have got that data and they're analyzing it, which is remarkable. We could never have done that before. Now, if what you have is an academic goal rather than, or an individual goal rather than an academic goal, I should say, then the development that exploded from the 1990s on was something called social software, or social media, which all of you know about, all of you who are under 30 anyway. One piece of this was services that helped you find the right person to contact, like LinkedIn. Probably all of you know what that is. If you don't, then you're not LinkedIn, obviously. The services could do this because they kept track of who knew whom for millions of individuals in a way that no human could do using these new software routines. And that was valuable precisely because it broke through the network ignorance barriers that had previously been so fundamental because they're based on human cognitive ability. But machines can do some things that we can't do, obviously. I did a search on the term social software in Google in 2006. And in 2006, there were 20 million entries. I did that search again a week ago, and I found 937 million entries. I mean, I didn't look at all of them, but that's how many there are now. I think it's safe to say that this sector is growing explosively. Probably the most famous kind of social software is social software that helps people keep track of those they know slightly, but have been out of contact with, their weak ties. And the first of these was, some of you will remember something called Friendster in 2002, now probably long gone. Facebook debuted in 2004 and now has more than 1 billion users around the world, including more than 40% of the U.S. population. Consider how much the U.S. population is under 2 years old. That's really quite impressive, because they're not. Although maybe I don't think they're. I don't think they have pages yet, but who knows? In June 2011, Facebook became the most visited web page in the world, and probably still is, with more than 1 trillion page views. We're getting numbers here that are quite amazing. Twitter emerged in 2006. Now has more than 500 million users, and by some recent counts, more than 58 million tweets per day. I'm not sure what people are doing with their time. It seems like all they're doing is tweeting and Facebooking and liking. So this explosive growth, I think, can be explained in some fundamental way by the limitations of the unaided human mind in grasping and using social networks, and the apparently limitless desire of people to maintain and use their weak ties to link themselves to a larger world. But the question of what the actual impact of social media is on the world is one that has seen surprisingly little good research. It's a great dissertation opportunity for lots of you here, in part because it's such a rapidly moving target. For example, in my own research interest, I think there is no clear answer to the question of whether social media have created important changes in the use of social networks to change from one job to another. If someone wants to talk about that in the Q&A, I'd be happy to tell you what I think about it. But one very interesting debate I want to review here in closing is whether social media play a major role, as has sometimes been claimed, in 21st century social revolutions and what we can expect in the future. So some writers and scholars who study information flow and social media argue that the advent of the internet and the rise of these media are a huge impetus to political freedom and a huge threat to despotic regimes around the world. They have argued, for example, that the unrest in Iran following the hotly disputed election of Mahmoud Ahmadinejad in 2009 and successful revolutions such as the 2011 one in Egypt, well, successful for a time anyway, were heavily driven by communication on such media as Facebook and Twitter. Some people have gone so far as to call Egypt the Facebook revolution. Others have hotly disputed this. I came across this debate when I read 2 articles by talented journalists, each of which used my paper, The Strength of Weak Ties, to take, to my surprise, completely opposite positions on whether this really was the case. So in a New Yorker article in 2010, Malcolm Gladwell, great writer, wrote an article called Small Change. You can tell from the title that he was in debunking mode. And the subtitle was Why the Revolution Won't Be Tweeted. And he notes that the U.S. civil rights revolution of the 1960s was a situation where activism was highly risky for participants, and as shown by the murder of 3 of them during the Mississippi Freedom Summer in 1964, and the thousands of arrests and the violence that attended the earlier sit-ins in the South. And then he cites research by others, including my Stanford colleague Doug McAdam, showing that those who stuck with the Freedom Summer movement, despite the huge risks, were those who previously had had strong ties to other participants. And so his point is that in high-risk situations, you need strong ties to pull you in. Weak ties won't do it. Weak ties not going to pull you into a dangerous situation. And then he says, look, Facebook and Twitter, what are they good for? They're good at diffusing information, and they're good because they foster weak ties. But that's not how revolutions are built. They're built on strong ties. And so he also argues that dangerous social movements require discipline and hierarchy, and weak ties don't lead to those. They lead to networks that work well in low-risk settings. But Gladwell's argument, so Gladwell is saying, no, this is not important for these social revolutions. His argument was challenged almost immediately by another talented journalist and writer named Jonah Lehrer in an article in Wired entitled Weak Ties, Twitter, and Revolution. So Lehrer also cited my Strength of Weak Ties article, but he cited a different part of the article from the part that Gladwell cited. And he cited the part where I talked about a Boston neighborhood that is no longer there. It was called the West End. If any of you know Boston, it's where the Charles River Park development is now along Starrow Drive. Used to be, I don't know if it's still there, a sign said if you lived here, you'd be home now. I don't know if that sign is still there. And so this is a neighborhood where people really loved living there. Everyone had lots of close friends. But then when there was a threat of urban renewal, which in fact eventually demolished the neighborhood, they were not able to mobilize to meet that threat. So how can it be that people who loved the neighborhood so much couldn't mobilize to meet that threat? Well, my argument in my paper was, well, the reason was that there weren't enough weak ties. And the argument goes like this. If you look at this picture on the bottom here, let's imagine that's what the West End neighborhood looked like. It was made up of, the fact that there are all these cliques is consistent with the idea that everyone has good friends in the neighborhood and everyone's very happy. Look how happy all these people are being in these cliques. I mean, you can at least imagine it. And here's the problem. The problem is that if the weak ties aren't connected, if the cliques aren't connected to one another, then an organization that's going to fight urban renewal might get started in one of these cliques. Maybe get started over in this clique here. If I can, yeah, there we go. But then it gets real strong in here, and then it doesn't go anywhere. And if it's going to start in another clique, it's got to start all over again. So you've got to have it starting over again in every clique. That's not going to happen because there are no connections. If there aren't any weak ties, which is how cliques get connected, then the mobilization's not going to spread. So furthermore, in this neighborhood, as in many settings, people are very wary of people who want to be leaders of a movement because they're afraid that they might just be out for themselves, that they're collecting money supposedly to fight urban renewal, and maybe they're just going to use it to go to Tahiti on vacation. How do they know? They don't know those people. And one reason you trust a leader is if you know them directly. But if you don't know them, if you know someone who knows them, who can vouch for them, then you might trust them. And if you don't know someone who knows them, maybe if you know someone who knows someone who knows them. So the shorter the path length is between potential followers and leaders, then the more likely you are to trust leaders and the more likely organizations are to get started. But if there aren't enough weak ties, then those path lengths are long because you can't break out between cliques, and then the mobilization is not going to happen. So I argued that might well have been what took place. So Gladwell and Lehrer came to different conclusions because they're looking at two different stages of social movements. Gladwell is looking at visible demonstrations like the ones in Tahrir Square in Egypt, where people come together and make their case in a loud and public way. Obviously, it's an important stage, but Lehrer is talking about an earlier stage, and at least equally important, where the movement is just taking shape, where people are forming an organization, and potential leaders are trying to gain the trust of potential followers, and that's very critical. Without weak ties, he argues, as I did from Boston, basically using my Boston argument, they might never succeed in establishing a following. Furthermore, Gladwell's idea that media only facilitate weak ties is too simple, because these media are highly adaptable, and we see them morphing into new spheres unexpectedly. So, for example, a fellow named Ramesh Srinivasan, who's an information scholar at UCLA, teaches information studies, he studied political unrest in Kyrgyzstan, I never could say that quite right, and found that a small elite of dissidents, 10 or 20 in all, who would have been killed if they'd all been present in the same physical place, were able to keep together by using social media like Facebook and Twitter in ways that they would never have been able to otherwise. It was very significant in a country that's hardly wired at all, but they had enough capacity there that they were able to hold together and get something started. So that stage is even prior to the one where leaders try to gather followers. They're just trying to survive and get organized. So social revolutions are complicated multi-stage affairs. What works at one stage may not work in another. And a really critical lesson, if you look at the latest research on this subject, is that at the end of the day, there's more going on in any complicated society than just networks of leaders and followers that determines whether a social revolution will succeed or be crushed. And one piece of this is highlighted by Srinivasan, who's also studying Egypt. He notes that social media in most countries are used by only a very small fraction of the population. Young, relatively affluent Egypt, under 5% use Facebook and 1% use Twitter, at least in 2011. It's probably increased by now. actually all this hype about how important social media are lead people to use it more. So there's a kind of self-fulfilling prophecy about it. Srinivasan notes that social media are situated within an ecology of other technologies, and they transmit images and information to the traditional media like CNN and Al Jazeera. These are not disconnected, and that makes a huge difference. So the old media and the new media are linked together, and that expands both of their influence in ways that are more than just additive. It's very interesting. Finally, Srinivasan, as well as others, such as a fellow named Evgeny Morozhev, who has a book called Net Delusion, The Dark Side of Internet Freedom, point out that social media and the internet are not only available to freedom fighters, but also to repressive regimes that have the resources to hire technical firms and consultants to help them root out dissent through these tools. So in Libya, the Gaddafi regime had quite a sophisticated operation of this kind. They'd lavished large sums on Western, mostly American consultants to help them manipulate social media. Morozhev calls those who fail to see this, he calls them cyber utopians. And he argues that governments are much smarter than we think in general. Mubarak's Egypt was an exception. They were very slow about this. This is one reason why they're not around anymore. But this is not the case in Iran, and it was not the case in Libya under Gaddafi. So the reality is much more complicated than we would like. Most realities are. To study the impact of social media and weak ties on social revolutions or other important outcomes, we need to keep in mind that while social networks may be critical and fascinating pieces of the story, as indeed they are, they exist in a cultural, historical, political, and institutional setting. And outcomes can never be understood if you don't take that into account. So that's a very good lesson for those of us who are interested in social networks. The way networks interact with these other elements is a long and important story, and this is certainly the next place to go for us to really understand what the impact of social networks and social media are. Unfortunately, my time is up, so it's not a story that will fit into these comments today. So thank you.
Yes. Comment more than a question, although
Larry, there's a mic coming.
interested in your response. One of the things, using the latest examples, and I'll illustrate this with a recollection from the Republican convention in Philadelphia in the year 2000. It was called R2K in contemporary lingo, in which a lot of activists were present and protesting, and that was just the period when some of these new technologies were available. And the activists, and I was somewhat involved in, peripherally at least in this, were totally enamored of these cell phones. And I forget the one that they were calling at the time. There was a particular model that was very, very popular, and completely oblivious to the fact that this was a very permeable network, and that the conversations they were having in organizing protests were very easily eavesdropped on by the people who weren't supposed to know about it. And I think one of the unspoken factors in exactly in what you were saying is that a lot of these networks, by virtue of their openness, mean that anybody can join them, and you have the weakest of ties.
Like the NSA, for example.
Yes, as we now know.
As we now know.
But that anybody can join, and the weakest of ties means really that you're unlikely to have somebody say, "Well, wait a second, who are you?" and who do you talk to, and where did you come from? Whereas the ones that are stronger, the sort of groups that were based on face-to-face knowledge, could resist that. And if somebody showed up, and just to use one example from that R2K, someone showed up in one of these groups that was planning a protest which would block a street, offered to help by driving people there in his van. They all got into the van, and he drove them to a police station where they were all arrested because that tie was so weak that nobody was there to question, this volunteer.
So I think one thing that's very interesting, and I wonder if when that started happening, whether that changed people's understanding of what was going on.
It took a while.
But you think it did eventually?
I think my experience with later groups is that they become more aware of, but still seduced by the attractiveness in the toys. Right. To realize, I think this, as you say, the NSA thing, I think awareness of the permeability of these networks has certainly reached a new level thanks to Everett's
I think there's a contextual question. So I think if you are in China, for example, you're a lot more aware of that kind of thing because the hand of the authorities is a lot less gentle and a lot more obvious. So I think people in Philadelphia thought they lived in a country where that didn't happen.
Well, they thought they had this magic tool.
That too, right.
And
Yep,
it's unaware of its consequences.
yep. Absolutely.
I've been following a social network for many years since it was begun, and I have a sense it's only been around for about 8 years. This community, and I have a sense that
What's only been around for 8 years?
couch surfing, and I have a sense that it's reached this point of saturation. And I know that when a lot of these networks emerged, there's a lot of hype about them. And I mean, something like this network is not really new. There was an old network that was offline that started in World War II called Servos. But anyhow, I have a sense sometimes that, you know, there's kind of this, while at the beginning there's this kind of a great interest, and I'm not saying that the networks aren't forever going to change the way people relate to each other, but to the extent that can be a lot of hype about it in the beginning, the kind of interest or involvement in it, I'm interested in how much you see signs of it maybe leveling off or even sinking a bit, and then maybe people starting to think, you know, we want to reconnect to each other on a more, level of face-to-face.
Right. I think a lot of people are interested in that question. I think there obviously has to be some leveling off. You know, after you have over 1 billion people on Facebook, you're obviously reaching some saturation point, so there has to be some decline. The question of whether all these online links reduce the number of offline links is a very interesting question, and I think that some people can get completely lost in the online stuff, but there are some who argue that people who connect a lot online then have many more people they can connect with offline. So it's a very complicated question, and you have, I think, a variety of different types of people doing this activity for a variety of different reasons. People keep predicting the imminent demise of these networks, but the trouble is that it's a moving target, and they keep developing and improving, and the fact that this is a for-profit sector, and certainly up where I am, people are just spending a lot of their waking hours figuring out what the weak points are in these social media, and how they can be patched up and fixed so that you can bring more people in, because there's a huge revenue stream available from that. And every time someone succeeds in that, it kind of pushes the envelope back again. So just when people think that maybe it's going to die down, then someone develops some new way of doing it, or some new wrinkle on it, or something to do with now that we have GPS and people can find out where their friends are at every given moment, and they never have to be, even though they're in a strange city, they can find their friends who happen to be a block away, which they never would have been able to do before. So there's always a new angle, and I think as long as there is profit to be made there, it's hard to predict where that will stop, because if I could tell you when it would stop, that would mean I know every possible future development, in which case I'd be so rich that I probably wouldn't be standing here now. I'd probably be on some South Sea island enjoying my big villa. So it's a very important question, and I think it's one that's not so easy to answer. So I'm not sure how satisfactory that is, but it's kind of where I am. Tom, you had a question?
Yeah, I now have to confess to misinterpreting the West End of Boston argument, because you've just presented it here that the lack of weak ties between cliques within the neighborhood is what led to its failure to mobilize, whereas I always interpret it as the lack of weak ties to external agencies, city council people, or other activist groups outside of the neighborhood that led to the failure. So
well, I think both things are true,
okay.
But the latter is not something that I emphasize. And you know, it's very convenient that I wrote this paper after the West End had been torn down.
Yeah.
So no one could go back and find out whether this was true. Now, I did talk to Herb Gans, who wrote the book The Urban Villagers, which was the ethnography of the West End, brilliant book. And he said that my account seemed quite plausible to him, having lived in the neighborhood for several years. But he also didn't have the data, you know. But I actually drew on his book and argued that the picture he constructs was one in which people were very ingrown. Everything was family and friends, close friends, and people were constantly with the same people. And to me, that was consistent with this very fragmented. He never thought about the fragmentation because he was with his informants. You know, he was doing ethnography. He knew the people he knew, and those people introduced him to whom? To the people they didn't know? No, they introduced him to the people they did know. So he was himself kind of stuck in one of these cliques. So it seemed plausible. Unfortunately, we can't go back and find out. It's unfortunate if my argument is true. It's fortunate if it's not true.
I was just wondering if you could say a few words about who are the people who create these weak ties. And in the similar idea in Bert's work where he talks about people with structural holes, people who bridge the structural holes, then gain informational advantages and they get promoted more rapidly in their work so that they gain an advantage for having these weak ties. So, but there's always been this confounding variable is that is it possible that it's just more entrepreneurial people who then create these network structures for themselves, and really it's their entrepreneurship and not their network that's gaining this advantage. But I'm just wondering, from what you've seen, especially in looking for a job, are there particular people who are the ones who create these weak ties, and do we relate that to certain traits of individuals, and are they gaining advantages from that?
So the question is, why do some people have more weak ties than others? Is it because they're entrepreneurial? If they're entrepreneurial, is that what's really explaining what's going on rather than the network structure? And this is a very important question. And I think that there is, if you read Ronald Bert's work, then he emphasizes the strategic advantage of having weak ties. And so his vision of all this is one in which people can construct these ties for their own advantage. And so it's what a rational actor would do. And there is a whole, you know, for a long time economists didn't think about social networks, even though in their private lives they knew they were important, but in their lives as economists they couldn't figure out how to model them, so they didn't pay any attention. This is kind of how economics goes. If you can't model it, you don't pay attention to it. I mean, for 50 years they knew how important uncertainty and ignorance was, but they couldn't model it, so they just cast it aside. Say, well, yeah, everyone knows everything. Let's just make believe everyone knows everything. And now there's a whole group of economists who do very sophisticated models of social networks. My colleague, Matt Jackson at Stanford, does a lot of this. He has a very interesting introductory textbook called Social and Economic Networks. And I think some of that is very good work. It's become a very lively subfield within economics. For me, the trouble with that work is that it is all, sophisticated as it is, it's all premised on the idea that people create their networks as investments and they have some control over what networks they're able to create. Now the problem is that sometimes this is true, but a lot of times your networks are not under your control to create, and you end up with the ties you have for reasons that have nothing to do with your own agency. So that's the question. So, and there are a lot of reasons why this might happen. So for example, in the Strength of Weak Ties article, well, maybe I don't talk about it in the article, but anyway, I contrast the west end of Boston to the north end of Boston. North end of Boston lobbied very successfully against urban renewal, and it was able, and it's still now a thriving neighborhood. You think mostly of the Italian part of the neighborhood, although there are some other ethnic groups that are there. And another neighborhood that was very successful at lobbying against urban renewal was Charlestown, which has a naval yard. And so the question is, why did Charlestown, the North End, lobby successfully and the West End couldn't? Well, it turns out that in Charlestown, the North End, most people work in the neighborhood. In the West End, most people worked outside the neighborhood. Now, why is that interesting? The reason that's interesting is that in the West End, in the neighborhood Gans talked about, people were in these cliques, which were defined by their very immediate surroundings and their family and close friends. And then when they went to work, they met people from other neighborhoods. They didn't meet other people in the West End. So that wasn't a way to break out of their cliques within the neighborhood. In the North End and in Charlestown, especially where there's a naval yard, some of you know Boston, almost everybody, the men, it was the men really who were at issue, they worked in the neighborhood. So that meant that at work, they met a lot of people who weren't in their immediate cliques, or in other cliques, and those weak ties bridge the cliques. And so my argument is that because of this happenstance, that the okay, I can try that. Is it live though? Yeah, right. But I don't. Does this sound any different than before? You think they can hear it downstairs through here? Okay, I'm game for it. It depends on how big the string is. So the argument is that people working in the same place are likely to bridge cliques of family and close friends. And so you get these weak ties between cliques in Charlestown and the North End in a way that you didn't have in the West End. Now, the fact that they happen to be working in the same neighborhood and that creates those weak ties, that's nothing to do with a strategic vision of how to create ties. It's a happenstance of the labor market ecology and how it intersects with social structure. And I think there are a lot of things like that where people's ties result in getting a job. I argued that one of the reasons some people have a lot of weak ties and others don't is that some people stayed in their jobs for a long time, maybe because they're so happy. And if you're in a place where everybody's happy, the other people stay in their jobs a long time. That's great. That's wonderful. Except if you ever have to change your job, you don't know people in other places. People who change their jobs every few years, they know people in each place, and those people scatter also. And after 4 or 5 job changes, you have weak ties all over the place, but you weren't changing jobs in order to create those. You're changing jobs for other reasons, but now you have all these weak ties. So what I would say is that people may try to structure their social networks for strategic reasons, and you might be able to do some of that. If you take a networking seminar, which is not hard to find, you can, if you have $500, you can take a networking seminar, or $1,000, or whatever they charge now, and they tell you, oh, you've got to meet 3 new people every day, right? And pretty soon everyone is running away when they see you coming because they know you're going to try to meet them because it's so artificial. I mean, I think there's something to be said for being aware of the strategic implications of making network ties, but I think that our ability to create our own networks is limited. And there are other factors that come in here that have a huge impact on who's in our networks that we don't have direct control over. And so that makes it hard for me to think that that's the main thing that's going on. Yes.
Can I
okay, well then, so we have an order here? Okay, well you have the microphone and then... And then
I'll pass it down, I swear.
Okay.
My apologies. Just as a preface, I'm a first-year PhD student, so pardon me if this question has any sort of ignorance about the field, but I was curious about this weird binary of strong and weak ties and how we could add some nuance to that. I'm thinking specifically, I'm coming from New York City, of my experience with Occupy, which, it being New York City and the people who were involved in Occupy being what it was rife with weak ties. It was just everybody knew everybody, especially because there were so many university people involved. But because the ties were through the university, weak though they were, and similar as they were to other weak ties, nobody took it seriously, and so I could never get any of my colleagues to come out to Occupy. Whereas the people I knew through work were more willing to come out, even though those were still what we would probably consider in this model weak ties. So I guess I'm just asking about what gray areas exist there and how they're important.
So you're saying all weak ties are not created equal?
Obviously, that's the case, but I just wanted to hear you elaborate more on it.
Yeah, well, sure. The article is very simplistic in the sense that it just talks about 2 kinds of ties, and obviously there are a lot more things you can say about ties than that. And I avoided being sophisticated about it because I thought that the more sophisticated I was going to be, and I avoided, if you read the article, you see I avoided doing any explicit mathematical modeling. And I thought that it was better to get the main idea across than to get lost in the details, even though the details might be very important. And so there are a lot of different dimensions of ties. Weak and strong is obviously a continuum. But the reason I used weak and strong is because I think that's how people think about it. I think people think about a distinction between acquaintances, and really good friends. And if you ask people which people are your close friends and which people are just acquaintances, people don't look at you and say, I don't know what you're talking about. People know what you're talking about, and they can tell you who's who. So it's a kind of a binary that people have in their heads, and because of that, it has some significance. That doesn't mean that that's all there is to say about it. Now, as you say, there are university ties, there are work ties, there are ties that are distinguished by the setting that you made them in, and that can make a big difference. And there are lots of different dimensions of ties that matter a lot. And I didn't try to do that in that paper, but I think that there is some literature that tries to talk about some questions like that. There probably needs to be more. So I agree with you that the weak-strong thing is a really very simplified account, and that we need a lot more sophistication about the quality of ties, the texture of ties, the nature of ties, the length of time, the amount of energy that goes into them. And with all the, this is one of the problems I have with so-called computational social science, with this emphasis on how wonderful it is that we can analyze data sets with hundreds and millions of nodes. That is great, but we also have to think about the texture of these ties and the meaning of the ties and what's going on in a theoretical way. You know, being able to analyze large data sets is not a substitute for ideas. It's a way to use ideas, but we have to keep coming up with new ones, and certainly how ties work and what the qualities are of ties that matter is something that hasn't gotten enough attention. And so the kind of thing you're talking about, I think it's very important.
Okay. First of all, I just have to say thank you for mentioning the hydrogen bond analogy, because it's absolutely relevant to something I'm writing, so thank you.
Good. Okay.
I was just wondering if I'm lying to my students, because what I tell them is that these strategically made weak ties often don't work, not only because people don't want to hear from them, but because their interest really isn't sincere, and you know,
That's right.
that. But that the way, what they should do is just to be curious about everything. And I find that people who are curious about everything, and you know, maybe I'm talking about a lot of people in this room, certainly me, tend to have lots and lots of weak ties, which become very useful, but just because you're interested.
Right. I think it's a very interesting problem. There is, in Peter Blau, the great sociologist, wrote a book in 1964 called Exchange and Power in Social Life. And one of the things he says at some point in the book, he's talking about how social approval from other people is rewarding. And he says at some point that social approval from other people is a reward for you unless you think it was meant to be a reward for you, and then it's not. So it's this question of sincerity. If you think that the reason people are acting as if they like you is because they're trying to get something from you, then that's a turnoff. And that's why this idea that you can keep making more and more weak ties strategically, you know, we're all on the lookout for people who are just trying to use us and who are just trying to make new ties for their own purposes, and they don't really have any particular feeling for us. So I think that, I think you're absolutely right, and I think that a lot of curiosity and a lot of interest in what other people are doing will lead you, in some cases, to people that you have an affinity to, and you'll form a tie. And if you don't, then what's the point anyway? I think that makes a lot of sense.
Thank you.
Hi. I wanted to ask a question sort of following your talk where you start about these very localized processes and weak ties and strong ties and the nuances of these dyads, and then end it really talking about these huge networks that we've observed, multiple types of ties, how relevant settings are, and where you think moving towards statistical modeling that encompasses all of these factors and that are really complex models across multiple settings with multiple variables is really the most useful way to go to understand these emergent properties, or it's really looking at the details of these parts of these systems?
Well, I think the statistical models of large systems are very interesting. And it's interesting, one of the things about network studies in the last 10 or 20 years is that it's no longer the preserve of social scientists. Now the computer science people, the physicists and others have really gotten into this because they see a lot of very interesting analogies. There are a lot of situations in physics, for example, where there are network processes going on. There's an old problem in computer science called the problem of cellular automata. And this kind of modeling is very interesting. If you look at some of the work on very large networks by physicists like J.P. Onella, for example, who's published in Science, there's some very interesting models, statistical and otherwise. Some of them are deterministic. I think it's very useful to do that, but I think that those models don't go anywhere unless there are some social ideas behind them. So I think that the problem is how you can get the people who are really proficient at statistical modeling and physical models about Ising models and other kinds of models in physics, how you can get them to either understand the social science part of it or get them teamed up with social scientists who can understand what they're doing in such a way that those models are put in the context of actual ideas about social structure that make sense. Because I think the models themselves don't tell you enough. They just are descriptive. So I think it can be very useful, but only if it's done in a way that links to some real ideas.
I'd like to go back to the Milgram experiment. Here I'm talking to somebody who actually knew the people who were carrying out experiments. Mm-hmm. The way I remember from the paper and from similar studies that were done, there were only about 20% of the paths or something were successfully found, or not paths of the respondents actually got their...
Were completed.
Were completed, right.
That's correct.
So what happened...
It might be less than 20%.
Right. So what happened? That people just ignored the task, or maybe it got stuck in a really long chain? You know, what happened to the failed, in the failed cases?
Well, what happened in the failed cases is someone didn't send on the postcard anymore.
Just like, so they didn't conduct, you know, it failed after 10 steps or something, so there was no way they recovered this partially completed?
You know, Harrison White, at that time, looked at all that data and modeled, he said, if in fact people are dropping out randomly, then what is the impact of that on the chain length? And in fact, the final number of 6 or 7 is adjusted is corrected for the dropouts in such a way that it reflects the fact that some people dropped out randomly. And so the ones that were completed were shorter than 6 or 7. But there were so many people, so many that weren't completed, that they had to try to figure out what that would look like if they had been completed. Now, I think that subsequent experiments have sustained the argument that people are dropping out for random reasons. You know, if it were the case that people were dropping out of these chains because they would be length 100 or something, mm-hmm. then that would be a problem for the idea that the typical chain is short. But there is a lot of evidence. Duncan Watts and others have done very large-scale experiments using email on Small World, and there's a lot of evidence that the dropouts really are more or less random, so that even though you have to take that into account, and it's certainly a serious issue, I think people have addressed that in a way that gives us some confidence that these short chains actually are fairly... And you know, the thing about a chain of 6 or 7 is that we think it's short because people used to say 100, 200, but it's not really short at all. If you think about how confident would you be about something you heard from a friend of 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 a friend, that's really quite long. In the sense that it takes you over hundreds of thousands, maybe millions of people, and you're not really getting much confidence of the sort that you get from someone that you knew personally or a friend of a friend even. So the idea that these are short is a little bit misleading, I think.
Yeah, on Facebook they're even shorter, like 4.3 or something like that. On Facebook the chains are even shorter.
Right,
yeah.
Right. But of course, the people who are on Facebook are not a random sample of the world's population. They tend to be literate. They tend to be affluent. They tend to, it's penetrating more. And so we'll see if that. And the people at Facebook, they have a whole group of social scientists there doing constant research on this, and some of it is quite good. So.
One last question.
It was a 29% completion.
29%. Okay, thank you.
Do you think the connections, these kind of weak connections, are have more value when they're serendipitous, when you end it with a thing like it's a small world, versus when they're more explicit, when you see it laid out in something like LinkedIn? Because I don't know how comfortable or opportunistic you can be when you see it, when you're 6 connections away from someone and you say, hey, here's how I know you. And it seems like it has a little bit more value when it's that cocktail party kind of setting.
Right. So you're talking about someone who doesn't really know you, but came across you somehow, or
you have that weak connection. It exists, but
so that's pretty weak. And I think that, I mean, I suppose each case is different, but I think someone you actually know from a real social context is probably a more valuable contact. We don't really know. So there's a very interesting question. Have services like LinkedIn changed the way people find jobs? And I don't think there's any good research on that. I'm skeptical that it has changed. I mean, it's obviously changed some things about it, but I think most people are not eager to find jobs that way, because if they're in a job that they're secure in, they don't necessarily want to be known to be someone who's sniffing around looking for other jobs. And that's what happens when you go online. You start contacting people on LinkedIn that you hardly know, you don't know at all, their friends of friends, and pretty soon everyone, including your employer, knows that you're out there looking for something, and I think this is a little bit tricky. So my guess is it hasn't changed things that much, that people still, in the end, use, and even so-called executive search services use you know, they're supposedly a substitute for networks, but the reason that some are successful is that they have networks. And so they're still using networks, even though they've kind of institutionalized it. So I think that what I would call the real weak ties are probably more powerful than the ones that are contrived, like the ones you're talking about. But I'm not seeing good research on that. And part of the reason it's hard to get research, if you go over to LinkedIn, and I mean, for me, it's just go over because it's nearby, and say, I'd like your data, they say, sure you would. And you know, you can get it if you don't mind, you know, that they put you a thing on your leg and chain you to a desk, and you have to use it there. The students have a lot of trouble getting that data. They're very jealous of it, as they should be, for privacy reasons. But that's why the in-house teams are most significant, but they haven't answered these questions satisfactorily yet.
Please join me in thanking you.